Alright, so welcome. Let's take a look at what sort of shenanigans we have going on here. As you can see, this is quite an operation. And I don't know, you might say this is a complete revamp of the solar power system. As you see, we have a newcomer here in terms of the equipment. Over here, we have the previous inverter, 500 watt pure sine wave, which used to be in there, but now it's being replaced by this enormous 3 kilowatt, 3,000 watt behemoth. Look at that. It's got a hardwire terminal down there. Whoops, I get a better close-up look at that. Of course, I'll be doing very extensive testing with that coming up soon, but for now, I want to show how I'm preparing to test that. So over here, we have the juicy lithium iron phosphate cells that we're going to use to provide power to that beast. Now these four in the front I've had for several years now. These ones in the back, they're essentially brand new, unused. Same type of cells, despite the fact that they look very different, and they're both the same rated capacity, despite the fact that they have different form factors. Now, I should first mention, I'm planning on putting these all in series. And each of these cells is 3.2 volts nominal. And so if I put 8 of them in series, we've got ourselves 25.6 volts nominal. So, in other words, a 24 volt system. Now, one concern that you may already be asking yourself is it a problem to put much older cells in series with much newer cells? And well, the answer is it's not ideal. It's not ideal because, yeah, because these cells are older, they technically have slightly less capacity than these. Now, I haven't actually done a capacity test on the new ones yet. That's still coming, that's down the line. But the capacities should be similar enough that it should be perfectly safe to put them in series as long as I have one of these. So this right here is a nifty little device. This is an active balancer, an active balance board. And it keeps all the cell voltages balanced with each other. And this particular one is specifically designed for an 8S setup, which is exactly what I have here. And that's why it has 9 connections there. And I just recently made up this this cable, or this spider of cables. I put ring terminals on here, so that took a little bit. Nice heat-shrinked ring terminals. Look at that, real nice. And there's 9 of them. And this is what, of course, I'll be using to connect the balancer to each of the cells down there. All of those and all of those. It's going to be one big pack. And this thing claims, although I have not tested it yet, but it claims it can do 5 amps of balanced current per cell. What that means is that it can essentially move energy from one cell to the cell next to it. So let's say this cell was at a lower state of charge than this one, at a lower voltage than that one. Well, then the active balancer can take energy from the cell and dump it into that cell, or vice versa. And it does so by repeatedly, very rapidly, charging and discharging these capacitors, and essentially shuffling the charge around. That's how I think of it. It's a pretty nifty thing. Now, if it can actually do 5 amps, that should be plenty to keep these cells at the same voltage, even if their capacities are slightly different. So I'm kind of banking on that working. So I guess we'll find out if it does.